Hi Internet, welcome to episode 8 of mentoring sessions on C++. In this particular session we are going to talk about the second part of the object-oriented programming in C++. In episode 7 we have discussed about couple of different topics, and those topics are actually from the uh, classes, inheritance, and the polymorphism. Within the classes we have actually discussed about the access modifiers, which is public, private, and protected, which actually defines that what are the limitations for the usage of the member functions and the member variables of a particular class through an object. Then we discussed about the constructor. Within the constructor we have actually discussed that how this particular method can do a default initialization of your variable which are defined inside the particular class. Apart from this, this can also be used for doing some kind of essential procedures whenever a new object is being created. We also discussed that this particular constructor is a function whose name is just the same as the class name, and it has no return type associated with this particular function name. Now, apart from this, we discussed about that how a class reference objects can be generated, and how by using an arrow operator we can actually utilize this particular reference in the real-time execution methods. Then we discussed about the friend function, that how some special operations can be done on the private member variables of a particular class through a friend function, which is not actually a part of the particular class, but we can make that particular function definition outside of the class, and by using a friend keyword we can include the prototype of that particular function inside the public section of the class definition. Then we discussed about the inheritance, where we spoke about that there are multiple types of inheritance: single inheritance, hierarchical inheritance, multiple inheritance. All that stuff we discussed about, and we have actually looked at that how one or more than one classes can be used to derive the another class, right? So this we discussed about the concept of the base class and the derived class, and we also discussed that how the base class member can be included in the derived class by using the access modifier, that is public, private, or protected, right? This defines that how the base class members are going to get included in the derived class under which particular modifier. So that is what we discussed in this. Then polymorphism we spoke about. The polymorphism is something which gives you a real-time execution model with respect to the mapping of the base class references to the derived class references. And we also discussed about the virtual function, which are the basic, where the small definition or curly braces block of code is being associated with the function which is defined inside the base class, and then it can be used to refer to the references of the derived class through the base class object, whereas base class pointer object specifically, whereas the abstract classes and the pure virtual function concept was discussed, where no definition block was given to the function in the base class, but the actual definition is provided for those functions in the derived class. So this is what we actually discussed in our previous episode 7. What about today's episode? We are going to discuss about the operator overloading, static members, and the class templates. So let's start with the operator overloading. Now we have studied about the function overloading, right? So what exactly happened in the function overloading? That we may have a particular function name which could have more than one type of prototypings, right? So let me show you what we discussed. So we said that int add, that has been used, and there is a int a and int b. There are two particular arguments which are being available. So I say return and a plus b. So this is what we do for the integer type variables, and same can be done for the float variables, where we can say that add method or function is going to have a float a and float b, okay, and then it can also return the value a plus b, right? So this is what we have. Same function name, but they have been overloaded by the difference of type of variables they are using, or could be a more number of arguments. So let's say I can do it as int add. This was for 2 numbers, and we can make it for int a, int b, int c, and this is for the 3 numbers. We can have a return a plus b plus c and then the curly braces is closed. So this is this particular example is for 3 function overloads corresponding to one single function, that is the add. So on the similar note, the operator overloading can also be done, and this can be done for the any selected operator which are eligible for doing the operator overloading. So whenever we are doing the operator overloading, it is by the use of a keyword operator, right? And this is the operator keyword, and the syntax is that whatever the type you wanted to return, whatever the sign you wanted to overload with the keyword operator and certain parameters, and this will be followed by the body part. Now mind that whenever we are talking about the type, we are actually talking about the user defined types, right? So this type will be some class that is going to have an overload for a particular set of objects with the primary objective so that to allow the operations to be performed on the object of the same type, right? So let's look at the example how exactly it works out for us. So this is the example which we have actually again fetched from the c++.com. So what we can see here is that we have a C vector class with the public variables defined under the public access modifier. So we know that there are 2 variables, that is x and y, which are of integer type. There is a default constructor C vector, and then there is a overloaded constructor where we are actually passing the parameter values so that it should be made eligible or made equivalent to x and y, which are the public variables itself. And then finally at the instruction number 10 we have the operator overloading. So if you look at this particular part very carefully, the first type, the return type, if just before the operator is the C vector, right? So this is what I'm talking about, the C vector. Then it has been followed by the operator keyword. The keyword which I'm going to overload here in this particular example is the plus, and then we are passing on a reference to a C vector object. Okay, now because this is just a prototype, so that means what we are going to have as a definition for that particular function. So here if you look at this particular part, because we are using the scope resolution operator, so I know there is a type and there is a class name whose scope having the operator plus overload function, and then we are having a constant C vector whose reference is being passed for the param. Now what we are doing here is we are creating a temporary object of the C vector class, and then we are adding the value to x and y. So whatever the existing value we have corresponding to my particular object, that will be added to that particular value. So params are, that means whatever the existing value we have, that will be added on to this particular simple vector, right? So in this particular case the overall implementation will be in the main method as that we create 2 different objects here, right? One is a foo object and one is a bar object, and there is another object which we create which is not been initialized. So that means we are going to have a call for this default constructor, okay? And then this this result is being equated with foo and bar, right? So in this particular case, what exactly is going to happen is the reference which we have passed over here, right, that will be added to the references to this, and then the result will be printed for both x and y. So x and y, that means this value x and y will be from that particular existing object, and then that will be further implemented, or that will be further added to the another object value. So here what exactly is going to happen, the current instance of x and y, that will be added to the next reference instance of x and y. So this is how the things are going to work around corresponding to my particular system. So we know that 3 and 1 is being passed, so 3 is being passed to x and 1 is being passed to y, and similarly 1 is for bar object, the 1 is passed to x and 2 is passed to y. So result should contain 4 and 3. So let's look at that what exactly it is going to have as an output. So I'm going to run this particular program, and you can see the 2 objects are being created, and the final value which is being printed is 4 and 3. So if you want to have more clarity, so we can have cout. So value for foo object of for x foo.x and y foo.y. Similarly we can have it for bar, and I can replace this foo by bar. Okay, and the result here is So what we have done is we have actually replaced the complete text message values in the result object X, and result object Y is going to be like this. So once we execute this, so you can clearly see that what exactly is going to happen. Now still the new line I have not put into this, so that's why this particular thing is in single line. So value for foo object for X is 3 and Y is 1, and value of bar object for X is 1 and Y is 2, and value of result object is 4 and Y. So let me do some more clarity here. I'm just putting up some more construct. So this is what I'm going to add here, and that's it. So let me run this again for you, and this should give you more clarity. So this is for the first object value, this is for the second object value, and once we put foo plus bar, that gives us 3 plus 1 as 4 and 1 plus 2 as 3. So this is what is the beauty of your particular constructor initialization, and then the operator overloading. The same can be done for the multiplication, and same can be done for the subtraction. So what I'm going to do is I'm going to make a copy of this prototype, and 1 2, so I'm going to do it for minus, and I'm going to do it for the multiplication, right? So same, I can make changes over here. So this is minus, so X is minus here and Y is minus here. So what exactly happens here is, like when we are doing this foo plus bar, so whatever the parameter or the member variables are from this particular object, they are going to be on the left hand side of this particular operator, and whereas the second, that is bar, is going to be passed as parameter to this particular operator, and they will be kept as a param here, right? So this is what exactly happens. So minus, I have done this, and same I can do it for the multiplication. So I can have this particular part as multiplication 2. So for this I'm going to put an H streak. I'm going to put an H streak here, and going to put an H streak. So make some more changes. So instead of doing this here, I'm going to put this here, right? And then I'm going to make a copy of this particular 2 instructions, and going to have the minus, and going to have a multiplication sign here, okay? And the values of result object addition, right? And then we have subtraction, and then we have the multiplication, right? So this is what we have, multiplication. Okay, so this is what we have. Now if I execute this particular program again for you, right, so this is what we are going to have corresponding to our result output. So I know that foo and bar both have the values of X and Y as 3 and 1 and 1 and 2. So for addition we get 3 plus 1 4 and 1 plus 2 3. Whereas for subtraction, so foo will be subtracted from the bar, so that means 3 minus 1 is 2, whereas 1 minus 2 is minus 1. Similarly, the result for the multiplication will be 3 into 1 is 3, and 2 into 1 into 2 is 2. So this is what can be done by using your operator overloading. You can do some more workout on the different kind of other parameters or other operators as well. So this is the basic working of an operator overloading. So the point here is that you are actually extending the functionality, the base functionality of the operator towards the user defined data types, which are basically what? A class, right? Class object. And you are trying to do the operation on that particular class object. And again, we know the associativity of our particular addition operators. So this is how the things are work. So left to right is what we have, and foo plus bar, that is why foo elements are directly available in this particular expression, and the second params are going to get the member variables for the bar. And this is the reason why we have kept this X and Y as a public section. Otherwise it's quite difficult to bring the values over here within this particular system. So this is how you are going to work around with your operator overloading. So let's look at a few more things. So here we said that overloadable operators are this. So we have done the operations on these particular thing. You can extend it for any of these operators as you want. there are few couple of operators which cannot be overloaded. So class member access operators are not overloadable. So that means dot operator and dot streak operator, they are not being able to overload it. Similarly, the scope operator you cannot do, which is scope resolution operator basically, and then size operator, which is size of, and the conditional operator, which is the also known as the ternary operator, which is used as an alternative of what if and else, single if and else condition. So that is what we have. So simply we have already seen the example. So what are the basic steps for the implementation of the operator overload? Create a class that defines the data type that is to be used for the operator overload. So C vector was created for that, which has two member variables x and y, two constructors we had, and one in fact we created three operator overloads, right? Three operator overloads were done, and that is what we have done. The declaration of operator function in public part of the class, it was done. Define the operator function implementation with the required procedures. So this is what is being done, where we have x plus param dot x and y plus param dot y, and they were being equated to the reference object of that particular variable. So this is what we have. So if I look at this particular code, this is what we have, the temp. Now why this particular C vector was created, it's clear, because we wanted to have the result returned with certain kind of object instance. So that is why the particular the temp is returned from this particular operator overloaded method, and then that will be referenced into this particular result part. So this is what you get in terms of your operator overloading. There are a couple of rules which you should be remembering while writing the operator overload. You should be working on the changing of semantics, not on the actual syntaxes or the parameters, right? So what exactly are the rules? So only existing operators can be overloaded, that we have already discussed, except the four operators. That is the class member references. One is the size of, one is the scope resolution, and the another one is the ternary operator. So they cannot be overloaded. Rest all can be overloaded, and there is no new operator that you can introduce here. Then operator overload must have at least one operand that is of user defined type. So as we have defined the C vector, so at least one operator should be user defined, right? So it's very, very important in that term. So we cannot change the basic meaning of the operator. So that means if addition plus sign is going to do addition, it will do the addition operation only. You cannot make it to work for the subtraction part. So it's a nomenclature which you should be following, and this is a major rule. It will create an ambiguity in terms of the logical implementation of the work, right? Then operator overload follows the default syntax rules of the original operation. So we know that the plus operation is being is in between two operands. So that is why we had the foo as a first object and bar as a second object. So you cannot change this basic notation. You cannot say that plus foo and bar is to be there. So this is wrong notation for the addition operation. Similarly, if I wanted to change the sign of the particular operator, in that particular case, what is going to happen is, if I wanted to have minus foo, so that means at least one operand is going to be there with the particular system. So this is a unary minus operation, right? So what this means that whatever the values are in x and y, they should be negated. So -3 and -1 should be the values that could happen in this particular case, right? So this is how the original default syntax rule should be followed with your operator overloading system as well. So this is very, very important to understand during placement interviews. These are the common questions which are being asked corresponding to the operator overloading. So simplest part for this particular operator overloading is that you are extending the functionality of operators for your class based objects, right? That's a simple thing which you should always remember, and take care of these rules, take care of these steps, and also take care of that which operator can be overloaded and which cannot, right? So that is it for the operator overloading. Next part which comes is a static member. Now static member is another beautiful property which has been included in C++. Now static variables are basically the class variables which are defined by using the static keyword. So that means if I have a class, let's say class test, and that class is going to have a variable integer a. So we are going to have a static keyword, SS small here, static keyword to be associated with that particular variables. That actually creates the static variable definition corresponding to a particular variable within a particular class. There is one more thing you should always remember, is that only one copy of static member is created for the entire class and is shared by all the objects of that particular class, no matter how many objects are being created. So let's understand this particular thing or this particular concept through a particular example. So let me write a particular program for you. So I'm making a copy of code and I'm just saving it. Alright, so I need to remove a couple of things from here. So let's say I do this. Maybe I'm removing this particular operator overload. Great, so I have made a minimum program. Now here what we can do is I'm going to define a particular static variable. So let's say static int obj count, right? So I'm going to use this particular variable for counting how many objects have been created for this particular class, right? So here what we can have is we can have the value in the constructor, right? So the default constructor, what it is going to have is it is going to have the obj plus plus, right? So what I have to do, one more thing, I have to send a initialization call for this particular variable. So I am going to write int c vector and then scope resolution operator and obj count. Now why I have done this particular part, so static variables are supposed to not to be explicitly initialized, but they have to be put into the definition part, so that it should get automatically initialized with the value 0. So at this particular point what it is going to do is, before we actually go and get into the particular set of object creation part, we should be defining this particular thing over here. Now what exactly I should be doing is, with every individual particular set of constructor call, I should be doing the obj count plus plus, right? So that's very important, because as many as constructors I am going to use, for all the constructors should have the same definition, because if I create a simple c vector and let's say f obj, that means first object I'm treating it as. So whenever f obj is going to get called, this particular constructor is going to get called, and then whenever the c vector foo or bar is going to get called, then this particular vector is going to this particular constructor is going to get called for that, right? So let me show you that how we can actually utilize this particular static variable. So static variables are, again, because it's scope is for with the class, not with the object. So what we can do is we can simply do a cout, right? And that cout is going to have the number of objects which are available for c vector class till now are. So we are going to have c vector, and then using the scope resolution operator I'm going to have a obj count, right? So this is how I'm going to have this particular value over here. Okay, now once I go and try to run this particular program, you can actually see that how with each object creation the count of the vector is going to get increased. The number of objects which are available for the c vector class till now are 1, and then 2, and then 3. So again, I'm really sorry, I every time I forget to put the new line escape sequence for the clarity, so I'm running it again for you after making that particular change. Okay, so let's see what exactly happens. Okay, the number of objects which are being available for the c vector class is 1, 2, and 3. So this is what exactly happens at this particular place. Now there is one more concept I wanted to discuss with you, that is named as a destructor object. So it is the opposite of the constructor. So what exactly destructor does? The basic syntax is this: tilde sign we use, and the name of the class c vector, right? And c then we can have a function definition correspondingly. So the basic work of this particular destructor is to release the memory that is being consumed by this particular object. So because we are releasing the memory and we are destroying the object, so that means we should also be destroying the object count as well. So we should be decrementing that particular object count as well. So a lot of time we might require the destructor for this particular purpose. So let's say if I'm going to destruct this particular vector object, let's say foo bar dot and tilde sign we utilized, and c vector, this is the destructor which has been called explicitly over here. Then we can do a cout, and that cout states the number of objects which are available after the destruction of an existing object. And then what we can have is we can have the same c vector to be printed over here at the end, right? So once we go and execute this particular program, we are actually able to appreciate the fact that whenever the number of objects are being created, they are being going to increase the static variable count value, and whenever the destructor is going to be called, that means whenever a particular object is going to get destroyed, in that sense we are going to have that particular count reduced. So overall you can simply say that the thing that we have is that there is a particular common memory location named as count, and that count will get increased whenever a new object is going to create it. So the objects which we created, one object which was created as foo, that once that object was created, the count was, because the default value was 0, the count was then increased to 1. Then there is a bar object which was created, then the count was increased to 2, and then another object we have created, let's say fobj, and then it was increased to 3. Whereas once the foo was destroyed, the because the destructor says, the destructor that we written as by using a tilde sign, and the destructor is actually written in the same way as the constructor are being done, c vector, and within this what we have actually done is we have reduced the count by 1, right? That has been decremented by 1. So that is the reason why this 3 is instead of 3 the value becomes 2, and once the bar will be destroyed it will become 0, and when the f object is being destroyed it will go to its initial value, that is 0. So this is the way how this particular count is going to have the impact of a single location to be shared among all the objects, and most of the time the static variables are used whenever we want a common value for all the objects to be shared with. So that is why we say only one copy of the static member has been created for the entire class and is shared by all the objects of that particular class, no matter how many objects are created, right? So a static member is automatically initialized to 0, that is what we have defined, and when the first object of its class is created and no other explicit initialization is permitted, then the static member variable is only visible within the class, but its lifetime is the entire program. So that is what we actually try to explain in this particular visualization. Now what next? On the similar note, we have static functions as well. So what exactly static function can have? A static function can have access to only other static variables declared in the same class. The static member functions can be called using the name instead of the object. So again, the functions are not associated with the object, they are directly associated with the class name. So let's look at the code again to understand that how these static functions work. So as we know, the static functions can only have access to the static variables or functions, another static function. So what I'm going to do is I'm going to have a integer return type, which is again a static integer function that I'm going to declare, right? The static function can be declared by using this particular set of notation. And here what I'm going to have is, let's say print object count is the variable, is the identifier name which I'm going to give to this particular part. So I'm going to return the value of obj count, right? So now instead of directly accessing this particular obj count variable, what I'm going to do is I'm going to simply replace this particular thing by print obj count, and that's a function name, right? I can pass on the any parameter if it is required, right? So instead of this, I'm going to call this and this. So this is how the static member can be implemented correspondingly. So let me run this particular thing for you. So here I'm going to have a okay, so is there any sort of mistake I have done, or so build? Okay, so I was actually running the previous program, that is why it was not showing me that build and compile and run. So I'm going to run it again. So here what we can see is the number of objects which are available for the C vector is again 1 2 3, and then this. So that means the same thing has been done by the function call itself, right? And in case if you wanted to have some kind of string which is to be passed back to this particular call, that can also be done here. So overall the static functions can be declared in a similar way as we do the basic function. The only difference is the static function and the static variables are only associated with the class, not with the objects, right? So even if we try to do it by using the object, we cannot have an access to these particular set of variables. So that is what we get in terms of our particular static member variables and the member functions. So let's go to the next part. So the next topic is the class templates. The template is an important feature of C++ which enables the generic type programming. When I say generic type programming, it's basically an approach where the classes are defined by using the generic types during its definition, and whenever we are going to initialize, or let's say whenever we are going to instantiate the objects, we are going to specify that what sort of suitable data type should be applied to this particular class system and its basic data structures which are being utilized by the while the procedure execution, right? The class template definition, if we look at the particular structure of what we are going to have, it's not structure, basically syntax. It's the similar way we use the template keyword, and that within the Angular braces we are going to have a class keyword, and then we have a particular type to be defined. Now this T could be anything. You can, last time if you remember, we have written it as any form or any type, right? So it's up to us, right? We can also give it as some type. Okay, so this T is something which is user defined. You can change its name. The only thing is that your template is to be put with the class. So here the use of the type T is generic. This prefix tells the computer that we are going to declare the template and use T as a type name in the declaration, which can be binded in the runtime. So now let's understand this particular class template by using a particular let's say program. So let me take you towards the program first. So here let's copy some of the required components. So I'm going to have a copy of this particular thing and then paste it. I'll clear some of the clutter out of this particular part. So maybe what I can do is I can have only let's say this particular section. Maybe I'm removing all these things, and similarly I'm removing these particular set of code, and I'm just only going to have a single cout statement, so that we can quickly understand that how this template can be specified. So here what we can do is we can have particular template. So let's say I'm going to have a template, and within the template I'm going to have a class, and that class will be resembled by, let's say, T, as we have seen in our slide example. So here what I'm going to have is let's say I'm going to define some kind of particular variable. So let's say T and first number, right? And that will be populated by using a C vector constructor. So we can have it as a first number equals to some value, that is T, and let's say user value. Okay, that user value is going to be passed to this particular system. Okay, so this is what I have right now, and oh great. So while initializing this particular part, what I can have is I can simply write, as we were doing in our particular set of function templates, we can pass on some value to this particular part, and here the particular foo object can print some value. So maybe I can have as void print value, and that value will be let's say printed by using a cout. This value, this line is to be printed here, the number of the value in first number variable is, right? And here I can simply put first number, right? And here I can simply call fobj right, obj, and dot, we can have the print value function to be called for printing the thing. So let me run this particular program to show you that how exactly this particular template can work. Okay, so missing the template f object template argument before the fobj. So we have actually, oh, I'm very sorry, we have to pass it on to this particular part so that this particular object can be initiated. So this is how the template is being going to utilize. So I'm going to have certain value, that is 3. The value in the first number a variable is going to have a value of 3 here, as I passed on the value 3 as a parameter to that particular user, right? So here also you can do a printing cout that user has entered the value as user value, right? And then I'm going to have that escape sequence of new line, and this is how you can actually print. So the point is that we have given a class template where the type was defined as t, and that type was given inside this particular system of this particular class, and then that type is being defined with the class itself while initializing the particular object, and that value can be utilized over here. Now same thing can be done for the particular another object. So I can have this particular object as the float, so I can simply use it as a float. I can use it as a double, right? I can use it as a double by specifying simple this. Okay, and so same foo object, let's say float, foo object, let's say double. So this is how you can actually go and do the printing correspondingly by calling their respective float object and the double object correspondingly. So if I go and execute this particular program for you, you can simply see that the user entered the value is 333, because for every part we have displayed the 3 value, and that is why the variable is being put for this particular part. So this is how you can simply do. And if you wanted to have a different thing, so let's say 25.53, and you can have 5 to this 0.5. okay, so in this case you are going to have your explicit values corresponding to your those set of functions. So this is what we get in terms of our particular set of things that are being provided correspondingly. So this is the way how you can do the class templates as well, on the similar note of the function templates. So finally what we have is in the class templates that this provides our generic programming approach to be utilized, and this is what has been also done by the use of the Java programming as well. So a lot of high level languages are allowing us to have a generic programming, and we can utilize one single set of particular program for the different data types which are decided at the runtime while initiating their or initializing their objects. So this is what we have for episode 8, and we have discussed about the class templates. We have discussed about the static members where variables and functions, how they are going to get used, and we have also discussed about that how the operators can be overloaded corresponding to your user defined data type procedures. So that's it for this particular video. If you have any kind of comments or if you have any kind of doubts to ask about, you can feel free to do it in the comment section or in the chat section, and feel free to ask that. And make sure you subscribe to our channel, that is Superwits Academy. Once you subscribe, do not forget to press the bell icon, because that will tell you that when we are going to have our next live stream, or whenever a new video is uploaded, that will be intimated to you. So this is what we have for today's session. And also we have started the training services. So if you have any specific training requirement with respect to Python, C, C++, Java, database systems, or the machine learning, then please feel free to send an email at hello@superwits.com. And you can also join us on Telegram. You can search for Superwits Academy and you can directly join into our particular channel, where we post our updates with respect to various kind of workshops and the live streams that we are going to have in near future. So thank you very much for watching this particular video. See you in next episode, in which we are going to talk about the special features, that is the file handling and the exception handling in C++.